Lesson 4. Classification of soil. 4.1 Classification based on grain size. In general, soils may be classified as coarse-grained, cohesionless, and fine-grained, cohesive, soil. The both coarse-grained and fine-grained soils can be further subdivided based on their grain size. According to Indian Standard Soil Classification System, ISSCS, soil with particle size greater than 300 mm is called boulder. Soil with particle size in between 300 mm to 80 mm is called cobble. The soil is called gravel if particle size is in between 80 mm to 4.75 mm. The gravel is subdivided as coarse gravel, 80 mm to 20 mm, and fine gravel, 20 mm to 4.75 mm. Soil with particle size in between 4.75 mm to 0.075 mm is called sand. The sand is subdivided as coarse sand, 4.75 mm to 2.0 mm, medium sand, 2.0 mm to 0.425 mm, and fine sand, 0.425 mm to 0.075 mm. Soil with particle size less than 0.075 mm is called fine-grained soil, silt or clay, and soil with particle size in between 80 mm to 0.075 mm is called coarse-grained soil. However, soil with particle size less than 0.002 mm is called clay, and soil with particle size in between 0.075 mm to 0.002 mm is called silt. 4.2 The Unified Soil Classification System. The Unified Soil Classification System (USCS), originally developed by Casagrande, 1948. According to this system, the symbols of the various soils are as gravel, G, sand, S, silt or silty, M, clay or clayey, C, organic, O, peat, peaty, well-graded, W, poorly graded, P. The soil is called coarse-grained soil if 50% or more soil is retained on the 0.075 mm sieve. If the 50% or more of the coarse fraction is retained on the 4.75 mm sieve, the soil is called gravel. On the other hand, if 50% or more of the coarse fraction is passed through the 4.75 mm sieve, the soil is called sand. Various types of coarse-grained soils are classified as GW, well-graded gravel; GP, poorly graded gravel; SW, well-graded sand; SP, poorly graded sand; SM, silty sand; GM, silty gravel; SC, clayey sand; and GC, clayey gravel. In case of well-graded gravels and well-graded sands, less than 5% soils pass 75 meters sieve. However, in case of poorly graded gravels and poorly graded sands, very little or no fines are present. Fig. 4.1. Plasticity chart as per Unified Soil Classification System, USCS. The soil is called fine-grained soil if 50% or more soil is passed through 0.075 mm sieve. The fine-grained soils are classified based on plasticity chart, as shown in Figure 4.1. The soil has low plasticity, Cl, clay with low plasticity, milliliter. Silt with low plasticity, if the liquid limit of the soil is less than 50% and if the liquid limit of the soil is greater than 50%. The soil has high plasticity, Ch, clay with high plasticity, Mh. Silt with high plasticity. However, more than one group can be termed as boundary soils, like GWGM, well-graded gravel mixed with silt. 4.3 AASHTO Soil Classification System. According to the AASHTO Soil Classification System, The soils are classified based on the group index (GI) value, which can be calculated as GI equals 0.2 A plus 0.005 AC plus 0.01 BD, where A is that part of the percent passing through the 75 meters, 0.075 millimeters, sieve greater than 35 and not exceeding 75. Expressed as a positive whole number, range 1 to 40. B is that part of the percent passing through the 75 meters, 0.075 millimeters, sieve greater than 15 and not exceeding 55. Expressed as a positive whole number, range 1 to 40. C is that part of liquid limit greater than 40 and not exceeding 60, expressed as a positive whole number, range 1 to 20. D is that part of plasticity index greater than 10 and not exceeding 30, expressed as a positive whole number, range 1 to 20. The group index should be rounded off to the nearest whole number. If the calculated group index value is negative, then it is taken as 0. A group index value equal to 0 indicates a good subgrade material, whereas group index value equal to or greater than 20 indicates a very poor subgrade material. 4.4 Indian Standard Soil Classification System, ISSCS. According to this system, the symbols of the various soils are as gravel, G, sand, S, silt or silty, M, clay or clayey, C, organic, O, peat, peaty, well graded, W, poorly graded, P. To classify the fine-grained soil, plasticity chart, as shown in Figure 2, is used. The difference between the plasticity charts used for Unified Soil Classification System (USCS) and Indian Standard Soil Classification System (ISSCS) is that in USCS, the soil is classified as high plasticity if liquid limit greater than 50%, or low plasticity if liquid limit less than 50% soil. But in ISSCS, the soil is classified as high plasticity if liquid limit greater than 50%, or intermediate plasticity if liquid limit is in between 35% to 50%, or low plasticity if liquid limit less than 35%. For example, if a soil sample has liquid limit WL 45% and plasticity index IP 25. According to the Unified Soil Classification System USCS, the point is above A line pointer in Figure 4.1, and it is classified as CL. However, according to Indian Standard Soil Classification System ISSCS, the point is also above A line point B in Figure 4.2, but it is classified as key. Figure 4.3 shows the flow chart to classify a soil according to the Indian Standard Soil Classification System. Figure 4.4 and Figure 4.5 show the classification of coarse-grained and fine-grained soil, respectively as per Indian Standard Soil Classification System. Fig. 4.5. Classification of fine-grained soil. A. Silt or organic matter. B. Clay, as per ISSCS. References Ranjan, G. N. Rao, ASR, 2000. Basic and Applied Soil Mechanics. New Age International Publisher, New Delhi, India. Suggested readings Ranjan, G. N. Rao, ASR, 2000. Basic and Applied Soil Mechanics. New Age International Publisher, New Delhi, India. Arora, K.R. 2003. Soil Mechanics and Foundation Engineering. Standard Publishers Distributors, New Delhi, India. Murthy V.N.S., 1996. A Textbook of Soil Mechanics and Foundation Engineering. UBS Publishers Distributors Limited, New Delhi, India.